So basically, there are several ways to find delta H. So one of the way to find delta H by using this formula. So delta H reaction is equal to summation number of mole multiply with delta H formation of a product minus with summation mole multiply with delta formation of reactant. Okay, so if we look at the example, nitrous acid is used to make many products including fertilizer, dyes and explosives. The first step in the production process is the oxidation of ammonia. So given chemical equation here and several enthalpy of formation of molecules. So the question asks you to calculate heat of reaction. So the question asks you to calculate delta H. So we can use this formula. Okay, so there are two products here. So number of mole of NO which is 4 multiply with this value plus with 6 number of mole of water multiply with this value minus with we also have two reactants. Okay, so 4 multiply with this value and then we need to memorize that enthalpy formation for oxygen is 0 because oxygen is at their standard state. Okay, so the answer is negative 906. So the question asks you to calculate heat of reaction. So the unit will be kilojoule because it is not specific. If the question asks you to calculate heat of combustion, if the question asks you to calculate heat of formation, so the final answer should be kilojoule per mole. Okay, so this is general heat of reaction. So the unit will be kilojoule. Okay, second example, the question asks you to calculate heat of combustion for propane. Given heat of formation for several molecules, so first and foremost, we need to write down chemical equation combustion of propane. So propane react with oxygen gas because this is combustion. It will produce carbon dioxide and also water. So according to the definition, so combustion is referring to 1 mole of propane. Okay, so this one must be 1 mole. So we balance the equation. So 3 here, 4 here, so 8. Okay, so we can use the formula. So delta H is equal with, so 3 multiply with enthalpy formation of carbon dioxide. So 3 multiply with negative 393.5 plus with 4 multiply with formation of water negative 285.8 and then minus with, so we have two reactant here. So again, delta formation for oxygen will be 0. Okay, so this one is 1 mole. So for this example, the answer should be in negative because combustion is exothermic reaction. And then the final unit will be kilojoule per mole. So this is the heat of combustion. The combustion of a sample of aluminium produces 0.25 mole of aluminium oxide and releases 419 kilojoule of heat at standard condition. So given the chemical equation here, calculate the standard enthalpy of combustion of aluminium. So, according to the definition, standard enthalpy of combustion is when you burn 1 mole of aluminium. So, according to this equation, when you burn 1 mole of aluminium, it will produce half or 0.5 mole of aluminium oxide. So, according to the equation, 1 mole of aluminium combusted, so it will produce 0.5 mole of aluminium oxide. Tapi dalam soalan, dia bagi tahu 0.25 mole of aluminium oxide will be produced and releases 419 kilojoule of energy jika kita bakar certain amount of sample. Tak tahu berapa banyak sampel aluminium dibakar. Okay, so kita kena buat stoichiometry. 0.25 mole of aluminium oxide dia akan being produced bila reaction tu releasekan energy this much. Okay, so kita nak kena cari untuk 0.5 mole because 0.5 mole of aluminium oxide produce bila kita bakar 1 mole. So 0.5 mole aluminium oxide is equal with, so kita buat stoichiometry lah. Negative 838 kilojoule. So when I combust 1 mole of aluminium, it will produce 0.5 mole aluminium oxide. So this is the amount of heat being released. So your final answer is delta H combustion is equal with negative 838 kilojoule per mole. Okay, so the unit will be kilojoule per mole because this one is referring to standard enthalpy of combustion. So 1 mole of aluminium being combust, so it will release 838 kilojoule energy. Question B. Determine the enthalpy of formation of aluminium oxide and write its thermochemical equation. So, tadi kita dah cari untuk combustion. Okay, so combustion 1 mole dekat aluminium. So, berdasarkan definition untuk formation, dia 1 mole of product. 1 mole of aluminium oxide is produced from its element. Okay, so tadi kita dah kira untuk combustion. Okay, so 1 mole dekat sini. So untuk formation, right now kita kena jadikan aluminium oxide ni 1 mole. Sebab kita ikut kepada definition. Okay, so macam mana kita nak jadikan 1 mole dekat sini? The whole equation kita kena multiply dengan 2 lah. So, if the whole equation kita multiply dengan 2, so delta H pun kita kena multiply juga dengan 2. So, kita akan dapat formation, enthalpy formation, negative 1676 kilojoule per mole. Okay, so kalau kita tengok soalan, dia minta write its thermochemical equation. So this is the answer. So thermochemical equation, chemical equation is on your left hand side and on your right hand side we have value of delta H. So untuk formation ni 1 mole aluminium oxide lah. So 1 mole aluminium oxide produce, dia akan releasekan energi sebanyak 1676 kilojoule.